Okay, all of the parts for my digital load project have arrived. Let's take a look at them all in the order they arrived. Firstly, I have the thermal paste. Nothing too special about it except for a couple of interesting errors in typing and font. I have two packages here from DigiKey. They also arrived in just one day. This one contains the USB port I'll be using. I'm forgetting the name of these, but it looks very nice and should work perfectly. This set, which I haven't opened yet, are the MOSFETs in a lovely static-proof bag. Very good. All 10 of them there. The next set of things arrived the next day, so 2 days after I ordered them. Firstly, a rather beefy heatsink which was wrapped in many layers of packaging. It had the bubble wrap bag, then it had a layer of bubble wrap, a layer of thin open cell foam that was very stretchy, and then another layer of bubble wrap. And yet FedEx managed to dent the corners. However, that shouldn't be much of a problem. This heatsink should be suitable for the power I'll be putting through it. To go along with that heatsink, two nice little fans. I haven't yet tested them. However, I shall do so, and they look quite nice, coming with a grill, which I did not expect, but is greatly appreciated. Those will be mounted on the back of the heatsink. I believe that these next ones came 3 days after I ordered them. I opened up this one to check its footprint on the PCB. It is the boost converter to step up the power supply, or the USB input, to 12 volts for the fans. Finicky little package, but it's about what you'd expect. Just a standard DC to DC buck converter, nice and cheap. Next is the ADS1115, a 16-bit ADC. I'll crack that open and we can take a look. As I hope you can see there, very small. Tiny, tiny chip there. I'm not sure of its package size, but this does look to be about the right size. Yes, I got the footprint correct and all of the pins correct. That's good. Next, we have this package that arrived, again, 3 days after I ordered it. It contains the current sensors. Now, it was the fastest shipping and cheapest one I could find, and so for some reason it came with some voltage dividers, which, honestly, I don't care for them. But it also came with two lovely 30 amp current sensors. Those. So I will desolder these and put the header pins on the bottom before putting it into the PCB. Now, the high current plugs, or terminal blocks. They're about what you'd expect. They don't feel too light. They have a nice wire thickness and they should be perfectly suitable. a few parts that I already have that I thought I'd mention. An Arduino Nano, which will be doing the PWM to control the MOSFETs, as well as a lot of the logic and communication. On top of that, there is also the Arduino Uno, which has a touchscreen shield on top. That will be the user interface. Now, the final box that arrived just yesterday. Took the liberty of opening it already. The PCBs came wrapped in a very, very heavy and thick bubble wrap. I only ordered 5 as that's more than I'll need. But now, taking a look at that, wonderfully shiny traces, nice, large and open. The surface finish is a perfect matte black. I haven't been able to find any defects with the surface finish in terms of thickness. One thing, however, the heatsink will be going in this footprint area, and it will likely be touching the MOSFET case for the high power input. Now, the thing about the MOSFET case is that it will be pulled to the voltage input. What this means is that you have your negative track going here, and the heatsink is positive. I was under the impression that they would cover the vias with surface finish and fill them with epoxy for my research. However, I am apparently mistaken. As they are exposed, I will likely have to cover them in something to prevent them from shorting to the heatsink. Not a big problem, just a minor inconvenience. Now, I'll check how all of the parts fit. Firstly, the heatsink. I didn't have exact measurements for every part of the heatsink, so I did have to open up MS Paint and measure the pixel lengths of everything just to get the ratio of length to, I don't know what to call this, base thickness. However, it does seem to be a fairly good match. I've already measured the base thickness once I got it. I thought it was 5 millimeters. It is only 4.5. Not a big deal. As you can see, that's the perfect width and perfect length. Wonderful. Now, this I measured, and it bothers me a bit. I'm not sure if the footprint was wrong, or if this is a knockoff that's just a bit smaller than they usually are. I will get another one of these after I'm done showing you. But oh, look at that. It's about 20% bigger, the footprint, than the actual component. Now I'll grab another one, just for reference, to make sure that this one isn't just tiny. Okay, here we go. This is the boost converter, and this is the buck converter. They do appear to have the exact same size. So, I'll tell you what, it's a real bummer, but the manufacturer must have given me, or the footprint must have been the wrong size. Well, that's quite interesting. Now, the current sensor. I believe I got the pin order correct. Looking at these PCB traces, that top one is ground, which, as you may be able to see, is correct. Out in the middle, yes, and VCC at the bottom. Okay, perfect. And of course, it doesn't matter which way you put power through this, it can handle positive and negative current through it. And the spacing does appear to be correct. Yes, that fits in there nicely. Now, the high current terminal block, which should go on this way. I made the footprint for this one, as they did not have one for this, and I could not find one on LCSC or a user-made one. Well, it appears that these legs are quite a bit too wide for these holes. However, they do appear to be a bit thinner than the holes, so I may just be able to, instead of drilling out the holes in the PCB, which would bother me greatly, I could just crush these down a little bit. Now, one other thing I noticed yesterday, I ordered 10mm pin spacing on these. However, they do seem to have sent me the 9.5mm one. Again, not a huge deal, just a minor nuisance. Now let's see what else I have to check. The ADC. First, let's make sure that the pinout is the same. VDD ground. Yes, SCL SDA. ADDR and alert. Yep, A0123. Yes, okay. I did get the pin order correct. That's wonderful. Now, let's see if this fits properly. Like a glove. Amazing. Now, let's see about the Arduino Nano. That appears to be a good fit. As you can see, when I soldered these pins on, they were not perfectly straight. So I would expect that with a small amount of bending on these pins, it will easily fit. In fact, I'll do that right now. There we go. Well, that looks wonderful. That should work perfectly. And the Arduino Uno. Now, I was very careful with this one, as screwing up the footprint for this would have been a bit catastrophic. I made the design choice that instead of using these header pins, which of course the touchscreen will be plugged into, having it upside down, that wouldn't work well for me. So instead, with the touchscreen on top, I will be using these smaller pins down here. Just indent it a bit, soldering header pins in, and then putting that down. So I made very many checks as to the spacing on it, and I can't think of any particularly good ways to show the spacing. However, it is correct. As you can see, the touchscreen does fit perfectly into those holes. However, since it's narrower, not both sets at the same time. And it also fits into these holes nicely. So the Arduino should fit down into there perfectly. Now, is there anything else? I've covered the heatsink. Oh, the MOSFETs. I will see if I can find one of the same package size. I don't want to open the package from DigiKey yet, as damaging the MOSFETs would really suck, even though I do have spares. The MOSFETs that I will be putting in here are TO220s. That's the package size. And so are these, so they should be the exact same size. As you can see, that fits nicely. I don't know how high up on the heatsink I'll want them, but I should be able to adjust that. So that should just about cover that. There are, of course, the resistors, which really the spacing isn't too critical. However, I did get the correct footprint size for all of those, I believe. And the thermistor, which is quite a bit smaller, and I will just thermally glue to the heatsink. Now, I will test fit the USB port. A perfect fit. Now, you may notice this copper area that's exposed around the pins. And I'll see how close I can get the PCB without it getting all blurry. But the deal with that is that I don't actually know which of these pins is VCC. I know that the case is grounded, however I don't know which of these 4 pins is the 5-volt power supply. I tested it on an Arduino, I looked for online pinouts, and basically they all disagreed with each other. So, of course, not wanting to have to reorder some $100 PCBs, I just made it so that I could bridge the solder from any one of these that I test with my voltmeter to be 5 volts. That way, no matter which one is 5 volts, I can hook up to it. Now let's take a look at the back side of the PCB. I've left all of these traces uncovered so that, if need be, I can add some copper wire and or solder. It should be able to handle the current just with these traces, but performance could be improved with the addition of solder and copper. I have some little exposed areas here for the fans, which have connectors on them at the moment, which I will have to cut off. Not a big deal. What else is there? I have little exclusions in the copper area around these places, which will be where the heat sink is bolted. So you'll see that will bolt into the heat sink, that will bolt in there and there. And of course you don't want the bolt that's hooked into the voltage supply to also be just a surface finish away from being connected to ground. I have these nice little edge bits which will serve to hold it up with some standoffs, which I have right here. Let me take one of those and see how well that fits. Wonderful. I did get the right size for M3. So I'll just tighten those down, have one on each corner, as well as 3 like that for a bit of extra support. Not mandatory, but you can see that'll hold it nicely off the ground, which will help a bit with cooling the traces on the bottom, as well as keeping them from touching the ground. That should be just about it. The only thing I have left to do is solder it up and, well, do a couple of tests regarding the PCB, ensuring that everything is connected correctly for how I will be using it. Well, come to think of it, I might as well test the capacitor and resistors to make sure they fit. I will mostly be using 10K resistors for this. I made sure to use only common values. And let's see here. Capacitor for smoothing out the PWM before it goes to the MOSFETs. Very tight fit. But that's perfect. And the resistors, don't expect to run into any problems with them. There, very good. I just noticed that some of the resistor numbers are out of order. Not even a problem or a big deal, just yet another little vaguely frustrating thing. So with that, I am done giving you the tour of these lovely PCBs that I've just ordered. Next, I will, of course, do some tests on them and then solder them up. Okay, I've done some test fitting since the last video, and now I'll just go ahead and show you all of the parts that I've managed to fit. Firstly, this high current terminal block, which I will not be taking off. I did have to use a file to remove a small amount of material close to this side of it, as the pins were not 100% straight. They went like that and then flared out into the connection. I'll get one and show you. As you can see, there's a tiny bit of a flare right at the end there. Now, that made it difficult to mount very, very close to the PCB, so I got rid of it. I also had to remove some material from the pins as they were too wide. I did try to make them as round as possible, so I'd have to remove as little material as possible. I believe they'll still be up to handling their rated current. Next, I managed to fit the ADC. Now, that's not exactly a feat of engineering. I did that last time. It just goes on like so. The current sensor, I will have to desolder this green block and put pin headers on the bottom, as well as swapping the side of these pin headers. That'll just go right here. I can actually push the pegs in a tiny bit and get it to hold itself there. The nano, I managed to put that in place last time too. This one's new, the Uno, with the touchscreen shield, which I have managed to place. I just needed to cut out some header pins, and thankfully I managed to get all of the spacings correct. I'll just go ahead and slot that on. It's a bit difficult to show as you have to have it at an angle to see it and line it up. But once it's on, which can take a bit of wiggling, it stays nicely. As you can see, perhaps, those pins line up perfectly. The USB port will go on right there, and I was thinking that for the boost converter, as the pins are a bit too far out and the whole model's off, I will likely just take some regular old pin headers and bend them inwards so that it works. I'm not entirely sure how well that'll work, but I could give it a shot. I'll just experiment for a moment with one here and see how well that goes. First, of course, I will remove everything else so that I don't drop any of it. Okay. If I just put one little pin header in, and like that. Okay. I'm going to get some small pliers to bend it. There we are. Now, I'll try bending it at a right angle, just to see what that does in terms of placeability for this part. If I now go ahead and put that in, along with that, you can see it does in fact shift it inwards a bit. However, that does not look like a particularly elegant solution to this problem. Let's see. What else could I do here? I could take a small section of copper wire and jump from the top to the bottom, but oh, the potentiometer has some pins that I don't want rubbing against the board. So it would be best if I could space them out. Well, I could solder two pin headers together in order to get the correct size, back to back, and bend each of them a bit. Let's see how that works. So, what I mean by that is I'd solder them like so. I can see that working. I'll get myself another pair of pliers to make it easier to bend. Here we go. Nice right angle. Keep that little plastic spacer straight if I can. Does appear to be rather difficult, though. I went a bit past 90 degrees. There we go. And the other one. Is not bent well at all. I will try grabbing the plastic spacer for this. These are some rather stiff pliers, so it is difficult to grab onto some small objects. And that has turned out nicely. Now if I take the other one, perhaps you can see what I mean. If I were to solder them like that, it would push it in quite a bit. Let's see if the soldering iron's heated up yet, so I can test that out. The soldering iron is hot, so I'll just go ahead and grab myself two of these little arm things. Clean off my area and then try soldering these pieces together. They're wonderfully small, so this will be quite difficult to line up. I may just hold the left one by hand to make this easier. Okay. And I will adjust this one so it's a little bit further out. There we go. Well, I should tin that first, and then I'll go ahead and see how well it will work. Not a superb soldering job, but if I do end up using this method, I will make sure to do it more cleanly. Now, I hope you can see what I mean here. Just a little squiggle like that. Now, if I go ahead and insert that into the board, and put the converter on top, okay. It does push it a bit too far inwards. It may make sense in this scenario to simply use some smaller pieces of copper wire. So I'll go ahead and see how well that works. Okay, I have a small piece of wire here, and I think I'll try using just the core, nothing else. Okay, let's see. If I were to go like that, I could cut out a bunch of pieces of the same length and solder them all at the same height, which would result in it being suspended just above the board, perhaps like so. Okay, well, I think that'll work quite nicely. Okay, what does that leave? I have the USB port, nano, uno, boost converter, high current plug, ADC, current sensor. All of the resistors and MOSFETs are fairly simple, and the capacitor. Well, that just about covers it. So, next I will start to solder down some of the components, just making sure to test them in between. Okay, now I'll be soldering up everything on this board. Firstly, I think I'll start with the boost converter, as, well, it seems like it'll be the most challenging. So let's see. First I'll cut out 4 roughly even sections of wire. This will be to connect it to the board, as the footprint, again, is wrong. Okay. Let's see. I think the best course of action here is to solder them all into the boost converter, and then proceed to solder them at the right length down to the board. So I'll go ahead and start soldering them to the boost converter. Should have tinned the wire first. Interesting. This board does not seem to be accepting solder the easiest. Okay, there we go. Just took a bit of time to get it started. Okay. This board is wicking away the heat very effectively, making it quite difficult to solder to. There it is, finally managed to get it through. Okay. Now that I've gotten all of those soldered, let's see how to fit it onto the main PCB. Making sure that it has the correct orientation, in plus, that is correct. Let's try fitting it into the PCB. Okay, I have all 4 legs in. This would work, however, this does not look good. So I'm going to try to push all of the pins through as much as I can. In fact, I will just gently use a small pair of pliers to help pull through. Okay, with a small amount of force, it's most of the way in. I'll just try to line it up with the middle there. I'd say that's about as good as it's going to get. Although perhaps I can make it slightly flatter. Yes, I'd say that's as far as it's going. And I must admit, it does look quite nice. Not as nice as if the footprint was the correct size, but it does still work. So, I will go ahead and solder that down. Now I'll trim the legs and double check the solder. Okay. Soldered down very nicely now, and I will make sure that all of them are trimmed as short as they can be. Okay, very lovely. So that's the first one. As you can see, it's quite solid. Next, I will put in the USB port. This is primarily to test that the boost circuit is working and that I have the correct set of pins on the USB port. I believe that the best way for me to do this will just end up being tack one down with a bit of solder, then get the rest. Making sure that it is nicely up against the board. Very good. I will now finish soldering that USB port down fully. carefully for these smaller pins. Don't want to bridge the incorrect gap. Thankfully, however, they all wicked up the solder very nicely. The port is solidly connected, although I do hear a bit of squeaking, so we'll just make sure that these larger connections are done fully. Okay. Very good. Now, I will go ahead and test to make sure that everything is working properly. I have a USB battery bank, as I'm working on a metal surface under this piece of wood, so I do not want to short anything. Nothing is connected yet, so I expect nothing to happen. I will now get my multimeter. Okay. Now, measuring the voltage across the pins. Let's see. So the case is ground. This pin is 50 millivolts. 50. Rising. And 50. Interesting. I'm still not entirely sure which of them is positive. I'm not entirely sure how to figure this out. I'll use a different USB power supply in order to determine the correct pin. I'll be back in a moment. Okay, I'm back. I've determined that the correct pin is the lower right-hand pin on the USB port. So, I'll just go ahead and bridge that gap with some solder. Very good. As you may be able to see, that pin is now connected. Now, that should connect 5 volts from the USB power supply to this boost converter, which I will now check. Okay, I have my multimeter. And power. Well, the power supply has not yet turned off, meaning that there are no shorts or misconnections. Now let's take a look at the output. 0 volts DC, and the input 17 millivolts. Interesting. I will try using the other USB power supply and see what results that gives. I've come to the irritating conclusion that it is actually the upper right pin. After checking the currents as well as voltages, it appears that this one is just pulled up through a resistor. Minor nuisance that I missed that, however it shouldn't be too terrible. I just now need to remove that solder bridge. Okay, I've removed the solder bridge. Next, let's connect it to the correct pin. The upper right hand pin. I'll now go ahead and, again, check the voltages. Hopefully, this time, they will be a bit more likable. Again, the power supply has not turned itself off, so that is a good sign. I'm reading 10 millivolts there, and 1.2 there. Not a good sign. Let's take a look. I'll take a look with my other power supply and see what that does. Okay, I believe I've solved the problem. After doing quite a bit more research, it turns out I assumed that the sheath was ground, and it is not. It is disconnected. So I did a slight modification on the bottom to jump the ground pin to the sheath, thus grounding it properly. Now, let's see how well that works. Currently the USB power supply is off, and I am reading how many volts DC? 73 millivolts. Close enough to 0. Now I've turned the USB power supply on, and I am reading, interesting, 100 millivolts. Peculiar. And now if I measure the input to the boost converter, still 75 millivolts. Interesting. What if I go ahead and measure the back? The power supply has turned itself off as there's no load. Turned it back on. Let's just check between pins. That's it, I seem to have misconnected it. Okay, I've made some slight modifications to the back. I've just jumped one pin over. It does seem that after some intense research for a couple hours, that I did assume the sheath was ground, although it was actually one of the smaller pins on the back side. I'm not quite sure why I made that assumption, but I did, and hopefully now it's fixed. Now, let's check the current voltage across the pins. I have some nice little jumpers here. 0.75 volts. Okay, now if I turn on the USB battery bank, or power bank, I'm reading 5 volts. Wonderful. Now across the boost converter, 5 volts, and on the output, I'm getting 5 volts. I'm going to go get a screwdriver, turn that knob, and see if I can get it to the right voltage. Okay, I'm reading 5 volts. Let's see which way it increases that. So that has turned it off almost entirely. Well, I've hit one limit, that's likely the lower one. Power bank has turned itself off again, as, once again, there's very little current draw. 6, 7, 8, 9, 10, 11, and 12 volts. Very good. 12 volts is the appropriate power across that rail, what it should be set to. Now I'll tell you what, let's take a look at current. If I just short it out, what'll happen? The USB power supply I'm using does in fact have built-in short circuit protection. So let's just see what this does. 2.5 amps, very good. Okay, that's perfect. Next, I should solder down... oh. I'll solder down the high current connector. Okay. Now, the high current connector, it's just sitting there right now. It's a very snug fit. And I'll just go ahead and put some solder on there to hold it down, and then make sure that it's as tight as it can be, because I do not want it wiggling around. Okay. Good, it does not seem to want to wiggle. And the second lead. I will of course add a bit more solder. But now there's a tiny bit of wiggle. Nothing all that significant though. So I'll just add a little bit more solder and see if that helps. Not really. Now I'll just go ahead and trim down these leads, as I do not need them to be that long. Very good. Now, let's see about the current sensor. Firstly, I need to desolder the high current bit, the connector. Unfortunately, I do not have any desoldering braid, so this will be a bit of a challenge. Okay, it's starting to come loose. I have already tested this chip, and it does seem to be the 30 amp version. I only passed 5 amps through it, but it handled that without even getting warm to the touch after a while. Let's see, I'll need to flip which sides that's on, so go ahead and use some small pliers just to grab a hold. Okay, that's coming off quite nicely. I don't actually need these pins. I'll be using some fresh ones, so I might as well just pull these off one by one to make it a bit easier on myself. Oh dear, that seems to have ripped up one of the traces. Well, luckily I have a second one. I'll go and get that now. This time, making sure to be extra careful with those thin traces, as they do not seem to be incredibly secure to the board. Okay, first pin removed, second pin removed, and final pin removed. So next I will solder some pin headers on there, of course only after I've taken this large high current bit off. It's a bit finicky to take off. Have to wiggle it back and forth quite a bit, but it shouldn't take too long. I've almost gotten it off. Now making sure to be careful so as to not rip any traces. The PCB's heating up quite a bit, but nothing too hot. Everything should be fine. Perfect. So now I have this blank board, which, after soldering some header pins into, I will put into the main board. Firstly, I'll do the high current pins. Using the PCB as a template, just to help keep the pins nice and straight. One at a time should make it easier. Okay, there's number one soldered on nicely. And number two. Okay, it's mostly soldered in. It's a bit difficult to put new pins into holes with solder in them. But again, unfortunately, I do not have any soldering braid. Okay, just straightening out that pin a little bit. There we go. That should fit fairly well. Next, I'll go and get some more header pins, this time for the logic side, which really just needs 3 header pins. So here we go. This one will undoubtedly be even more difficult, as I have to get all three in at the same time. Though, if I pull the plastic insulating bit off and then stick it back on later, that could make my life easier. But it could misalign the heights. I'll try simply soldering it on as is. Does not seem to want to solder on. Try adding a bit more weight to the bottom of this in hopes that I can get a little bit more force to push down. And that seems to have done the trick. Now I'll just clean up each one of them. Perfect. Now let's see just how well this fits onto the main PCB. Like a glove, even the footprint matches perfectly. You'll love to see it. Now, I'll just go ahead and solder that down to the high point traces. Second one. Very nice. Then I'll do these logic traces. Very nice. Now I'll go ahead and trim each of them. Watch out, there'll be a little pop. Okay, and then I'll go ahead and clean up all of those little soldered points, just to make them look nicer. Wonderful. That's coming together nicely. Now, I'll go ahead and solder down the ADC. I think what I'll do is solder down probably on the main PCB first, as it seems to be keeping it nicely straight. Just have to make sure to push it through all the way. Now that that's nicely vertical, I'll go ahead and go for the actual board, making sure to keep it nice and parallel. Very good. I'll tap on the other side. Perfect. Now I'll go ahead and do the entire bottom, just to make sure it doesn't drift around at all. Then I'll go ahead and trim all of those down too. Watch out for headphone users, a little pop coming. There we go. Now I'll go ahead and finish off the top side. Okay, no solder bridges, very good. And I'll just clean up the bottom. Okay, very good. Well, now it's coming together quite nicely. Well, that looks quite nice. However, I'm not sure. I may want to put it on header pin so I can remove it. Oh, actually, I'll tell you what, this isn't fully seated. It's not quite all the way down yet, so I'll just have to go ahead and push it down a bit. Still, not quite fully seated. Doesn't appear to be going down any further. That one's going to bother me. Okay, I'm going to continue trying to reseat the ADC, as if I don't get it, I know it will bother me forever. Okay, it's going in a little bit. This may just take a few more minutes. Not fully reseated yet. If I put it on top of these pliers, then it should allow me to push down evenly and straight down. It does not seem like I will be able to reseat that. Minor nuisance, but not a big deal. Now I just need to get rid of any solder bridges that I've made. Okay, guess I'll just have to deal with that not being perfectly flat. Let's see about the nano. I'll see if I can still plug into it, because I will have to program it, as the software is not done at the moment. And that is a very definite no. Okay. This means that either I'll have to have it a bit higher up on the board, or have it removable, which I think may end up being a wiser idea. Okay, that should work. There we go. I do have to admit, though, it's a bit of a bummer, as if it had working software on it already, that would look a lot more sleek. Well, bummer. This time I'll make sure that it's seated before continuing. It appears to be. So I will go ahead and solder every single pin. Okay. And with that, the Nano is seated. If I ever run into any problems with it getting destroyed, which hopefully will never happen, I'll be able to replace it. Now for the Uno. I should be able to program it without unplugging it, and it will not be in contact with any high power, so I shouldn't have any reason to have it replaceable. So, I'll go ahead and insert all of these the correct way, and then solder them into the Uno. Of course, I'll make sure that I can still program it, as if I couldn't, that would really stink. Okay, that'll work just fine. Now, holding on to it, I'll go ahead and solder down a couple pin headers just to hold it, and then I'll make sure that it is in as far as it can go. Come to think of it, it may be a smart decision to solder it onto the Uno first. Well, would it? No, it would be a bit finicky. I'll just solder down each set of pin headers, and then put the Uno and solder it. Now I'll make sure that it is seated properly by pushing on the Uno and resoldering each pin. That seems to be correct. Now let's take a look. They do all seem to be put in appropriately, except these two. Okay. I'll go ahead and check to make sure that that will work for the Arduino Uno. I can line up all of the holes. seem to line up. The holes, they're a bit too far apart. So we'll just pull them all in a little bit. See if that can get it to work. There we go. That should work for all of those pins, and the bottom still seems good, so I'll go ahead and finish soldering the bottom. Okay, so the bottom's all soldered down. I'll go ahead and trim all of the pins. Okay. That's very good. Now all I have to do is solder it down. Again, just double checking that indeed I have enough room to program it. Now, I'll be fairly careful here, as screwing it up would be, again, quite a bummer. All of the connections appear to be fairly good. And look at that, perfectly within the footprint. Solidly held down. I'll go ahead and put the nano back in. And the screen. That is, for the most part, the control electronics done. Now, let's see what happens when I go ahead and plug it in to the USB. I just have a small demo sketch loaded on. It seems to be drawing 1 amp or so. If I remove the screen, it is only drawing 20 milliamps. The nano does seem to be spazzing out ever so slightly. If I go ahead and remove that, put back the screen, $250 milliamps, and the nano. Interesting, this current draws a lot higher than I would have expected. Just feeling for any hot chips. I believe that the problem could in fact be that Arduino Nano that I plugged in earlier. Or not. Still 1.15 amps. What could that be? The boost converter doesn't seem to be getting incredibly hot, but it's definitely not a good temperature. I'll have to do some investigation into where that current draw is coming from. Now let's see. Is there anything else that I can solder on? I'll need to print out all of the resistor values as I do not remember them. I'll need to put the MOSFETs in, which I will. I can do 2 of them now, I'm just not sure how high I want those on the heatsink. And I can do the capacitor now, so I'll go and get those. Here we go, some IRL 640 MOSFETs. For now, I will just put the lower power ones in, one at a time, I suppose. Making sure that it's all the way in. I seem to have managed to push it a bit too far in. Never managed to do that before. And I believe that's incorrectly. So I'll go ahead and solder down the other two legs. And snip off the excess. That last one I soldered is to pull down the voltage sensor's input if ever the input voltage is too high, just to prevent it from getting too high of a voltage and being damaged. This one that I'm soldering now is to control the fans with PWM. And there we go. Two MOSFETs soldered on nicely. This one is ever so slightly crooked, so I'll just go ahead and try to fix that. Just making sure that the MOSFETs don't heat up too much. Okay, those two MOSFETs are done now. The 4.7 microfarad capacitor for smoothing out the Arduino's PWM. Again, just making sure the component is all the way in. There we go. Next I'll do the resistors, however, again, I do need to figure out what values they're supposed to be. You can see now that it's almost done. With that heatsink on the back, it is going to look amazing. Almost like a little city. Well, I'll go ahead and find the resistor values. Okay, I now have a picture of all the resistor values, and I'll go ahead and start soldering them. Firstly, a 22K for the low pass filter, or for that, I happen to know which pins it's on. They're right next to each other, R3 and the capacitor. Okay, now I'll go ahead and solder that. And cut off the leads. Okay. Very nice. Now I have to put two 10Ks, R1 and R2, on these serial communication lines. Okay. I have a nice big bag of 10K resistors from another project. I'll just go ahead and get 2 of them. And put them in their places. Okay. Now I'll go ahead and trim those down. There we go. 2 more. Okay. Let's see. 4. For V-Sense, I need a 10K pull down. A 10K pull up. And a 100 pull up. These two will be in series with this one on ground. Now I need to figure out where these resistors go. Okay, R4, 5, and 6. Those will be them. As you may be able to see, there are 3 resistors in series, which does not happen anywhere else. Now I'll check to see which ones go where. R4 is 10K, R5 is 100K, R6 is 10K. 10, 110. And the final 10K. There we go. I'll go ahead and solder those down. And now we'll snip off any excess. And then tidy up all of the solder joints. And just like that, I have all of those soldered in place. Next, I have the overvoltage sense ones, R7 and 8. R7 needs to be a 470K, and R8 a 10K. This is just so that it can sense absurdly high voltages without coming close to damaging itself. It does not need to be able to sense such a crazy voltage range, but it also doesn't need the accuracy, so why not? There we go. R9 is part of a voltage divider made with the thermistor. So the thermistor and R9. And yes, it's meant to be 100K, I believe. But I do need to find the thermistors first, as I seem to have lost them somehow. Once I've found them, I'll check their resistance and then solder in the thermistor and R9. But for now, that's about all the progress I can make. Alright, so I've put in a bit of work and gotten the heatsink all mounted. drilled some holes, tapped them, put bolts in, and I also have the fans in. Had to use an angle grinder to remove some of the material just so I could press fit them in. They're quite secure. I also found the thermistors and put in its resistor too, so it should be able to sense temperature now. And I'm just going to start soldering on the fans, just like so, to each of their headers. Very nice. Now I just need to get this second one on, and the fans will be completely mounted. Amazing. So, the fans are both mounted, nice and tidy. Now all that's left are the MOSFETs, which will be a bit of a difficulty, as one of the leads is actually thermally connected to the case, so that'll be a bit of a challenge. Okay, I've got these bolts. They're the same as the ones I used to mount the heatsink to the PCB. I'll be using them to hold the MOSFETs down. And of course a bit of thermal paste with typos on the back. I'll just go ahead and open that up and get it out. Okay, there's the tube of thermal paste. Nothing else in there. A little instruction manual I'll put off to the side. I believe they include a little spreader. I'm not quite sure what this is for. So, grease cleaner. Ah, they're to clean off the heatsink. Okay. Now I have the MOSFETs. I got some spares. I only need 4, but I don't know, I have 8 or so in here. So let's see. Has some instructions here. Okay. Still can't quite tell what this is for. Oh, I'll tell you what. I believe you're supposed to put it down on top of any processor and then use it to scrape it out after punching the holes out. So let's see if any of them fit the MOSFETs. It's a bit difficult to see. Let's see. No. Okay, so I'll just be freehanding this. Let's see, how am I going to do it? Probably one FET at a time. Should probably use the one wipe to clean off the heatsink and the other one to make sure all the MOSFETs are clean. So I'll just go ahead and get all of these out, might as well clean them all. With my stellar intelligence, I've managed to use the dry wipe before the wet wipe, so let's try that again. suppose they'll just have to be extra clean then. And then the heat sink. And next, the dry wipe, I suppose, again. Just making sure not to touch the backs with my fingers, because that could get them dirty. I'll go ahead and put them back and then take them out one by one as I need them. Okay. Let's see about the thermal paste. Has a little plastic wrapping on it. I'll see if I can't take that off. Not by hand, I'll need to use a knife. And that's gotten it started. So we'll just use some tweezers to help take it off. There we go. And let's see. Okay. So, I'm probably going to take a MOSFET, cover it in thermal paste, just a nice thin layer, and then put it on the heatsink, bolt it down, and then solder it to make sure it's in the perfect spot. So I'll just go ahead and use this to spread it, get a rag just so that I can clean any excess off. Okay, first one, making sure not to touch the case. Never dealt with thermal paste before, but I've heard that you're really not supposed to use a lot. I have no idea how viscous it is, so just going very slowly. Okay, that should be more than enough. Capping it off to make sure I don't get anything in there. Then I'll go ahead and use this thermal paste spreader just to get a nice even coat on the back of the MOSFET. Okay. Now, a I'll go ahead and carefully pick that up, making sure to keep the thermal paste clean. And let's see. Probably best if I use some tweezers to hold it, then place it in its hole, making sure only to let it touch the heatsink when it's in the right spot. The thermal paste holds it down a little bit, so now I can take a bolt and put that in. Seems I got just the right amount, as there's only a tiny bit squishing out around the edges. I'll probably clean that all up at the same time. You can see it's sticking out a little bit down there for soldering, that's great. Now I suppose I'll just move straight on to the second one, solder them all in one go. Okay. Next I'll apply some thermal paste. This time I'll spread it out a bit more beforehand. And I'll take the thermal compound spreader and just go ahead and even that out. I don't seem to have put enough on, so I'll just put a second dab. And smooth that out again. Just want to make sure that I have the best possible contact with the heatsink, considering how much heat this will be putting out. Okay, that should be good. Now again, I'll go ahead and carefully pick it up. Before gently placing it down in the right spot and bolting it in. Making sure to get it nice and tight, good thermal contact, and I'll go ahead and move on to the third MOSFET. faster at this now, and a lot more even. So again, just picking it up. You can see everything's covered in a thin layer. Doesn't need much, just enough to fill in any tiny gaps with the heatsink. Placing it on. And then I'll go ahead and bolt it down. Okay, and the fourth and final MOSFET. We'll go ahead and close this back up. Add some thermal paste. I bought this thermal paste off of Amazon, and it was $8 or $9 for this 4-gram tube, but then the 3-gram tube was $12. So, although it's way more than I needed, it was cheaper. Okay, that does seem to have a coat everywhere on it. So I'll just place it on the heatsink and bolt it down. You may notice a bit of roughness around the hole here. Drill bit got stuck, so I had to take it out. Well, it broke very, very close to the material, so I used a flat metal bar and just hammered it out from through the fins. And there we go. Now we'll go ahead and just clean up around the edges here. Well, I may need to use one of the wet wipes they provided for that. Not perfect, but for first time using thermal paste, I'd say perfectly acceptable. Now, soldering on the bottom. This will be an adventure, as, again, one of the pins is thermally connected to the case, so it could be rather difficult. Pins are very close, and jumping them would make everything more difficult. So we'll just have to be very careful. I'll have to go back over all of the pins just to make sure that they're soldered as well as they can be, just to minimize resistance. I think it may actually be that pin 3 on the MOSFET, that is thermally connected. That's definitely the pin that is connected, so I'll just turn up my soldering iron and hope for the best result here. I'm just taking a look now at how far through the solder has gone on all of them. I believe that first one is fully done. The solder almost doesn't melt, even though this iron is a lot hotter than I usually leave it. It just looks up so much heat. Okay, let's take a look at that. That one's fairly good. All three of those are clean. These three appear to be clean. That gate could use a bit of cleaning up, and these three appear to be clean. So I'll just go ahead and give this one a touch up. And there we go. Now the tops. All three of them appear to have solder going almost all of the way through. This one, the middle leg, pin 2, could use a bit of touching up. Still not quite perfect. I'll just go ahead and solder all of the high current pins a second time just to ensure that they're all fully connected all the way through the layers. That gate could use a bit of touching up, and pin 3 over there. Pin 3's looking good, that whole FET's looking nice, that one's good, and that one's good too. So there you have it. Everything assembled. I'll just go ahead and put on the screen and nano. I still have to program them, which is a whole other adventure. But that's basically it. Except these two MOSFETs, I kind of want to straighten them out. Oh, I already tried. Well, maybe I won't. They're only a tiny, tiny, tiny bit off. But now, the standoffs. I figured that these bottom screws could make a nice round foot, make sure it doesn't scratch anything, and hopefully its weight pushes down hard enough to keep it fairly stable and still. So now let's go ahead and just put all of these on. I'll just finger tighten each one, and then put it in fully. Proving to be rather difficult. Well, I'll just go ahead and use the screwdriver on all of them. I made sure that all of the layers around it were ground, so there should be no problems with this whole thing sitting on a metal surface. One thing to note, the heatsink, as it's connected with bolts to the MOSFET case, depending on the MOSFET, it could be connected to different voltage rails or different pins. In my case, it's connected to the positive voltage in, so touching the legs to the heatsink could be a problem. Generally, though, I don't think I will be doing that, so I should be fine. There's also a thin layer of double-sided tape which helped me keep it down while bolting it, and it also helped with, some of the vias were exposed like that. The surface finish didn't quite cover the vias, and I wanted to make sure they were insulated from the heatsink as the vias were grounded, so that sticky tape helped with that. There it is. Not yet coated, however, almost fully functional. All that I have left to do is replace this boost converter, as this one, again, does not work particularly well, and just code the Nano and Uno. There we go.